In this topic, we'll open the black box of qualified electronic signatures. You'll see how a bank application talks to a remote signing service, how users are authenticated, and how the architecture keeps signatures both secure and legally reliable from end to end. Up to now, you've seen the foundations, the use case, and how identity proofing works. Now we'll zoom in on the qualified e-signature architecture, how remote signing services, QTSPs, and your bank application work together in practice. We'll then complete the picture by showing how the solution produces evidence and supports compliance. When we talk about local signing, think of smartcards or USB tokens. The private key lives with the user, and signatures happen on their own device. Security can be strong, but usability is fragile and depends on specific hardware. Remote signing flips this model. Keys sit centrally in a hardware security module, operated by a qualified trust service provider. The user simply authenticates, usually via web or mobile, and the platform performs the qualified signature on their behalf. Remote qualified signing isn't only about meeting legal requirements, it's also a strategic choice. Because keys stay in secure hardware at the QTSP, customers no longer need smart cards or readers. The bank gains consistent compliance, centralized certificate management, and outsourced cryptography. That simplifies operations and makes it much easier to scale across channels and countries. A qualified signing solution is basically four moving parts working together. First, the user interacts with a signing front end embedded in the bank's web or mobile app that hands control to an orchestration service which decides what needs to happen, when, and with which provider. The orchestrator then calls the QTSP platform, where the user's qualified keys are held securely and the signature is applied. Finally, certificate management covers issuance, renewal, and revocation over time. In an eIDAS solution, a clean trust boundary between the bank and the qualified trust service provider is crucial. The bank owns the customer relationship, the interface, the routing of users, and how signing is embedded into business processes. The QTSP owns the cryptographic core, secure hardware, certificate issuance, and strict policy enforcement. Between them sits shared responsibility, identity proofing agreements, SLAs, and incident handling. Architecturally, all three areas need to be designed and documented very explicitly. The signing front end is the user's window into the qualified signature process. Its job is simple but critical. Present the contract in a readable way, ask for clear, explicit consent, and make the legal nature of the action unmistakable. Strong UX also highlights eIDAS trust marks and security cues, so users feel confident when they click Sign with QES. The signing orchestrator is the brain between the bank and the qualified trust service provider. It receives a request from the banking backend, enriches it with the right policies and user context, and then drives the interaction with the QTSP APIs. It also tracks active signing sessions and callbacks, so the front end always knows the current status. By centralizing this logic, the bank stays decoupled from vendor-specific protocols and can swap or add QTSPs more easily. The QTSP platform is essentially the secure vault of the whole solution. Customer signing keys live inside certified hardware security modules and never leave controlled hardware. The platform automatically enforces eIDAS and ETSI policies and exposes APIs that let the banking application request qualified signatures on demand. This setup achieves a very specific goal. First, the bank or an identity proofing provider verifies who the person is and sends those trusted attributes to the qualified trust service provider. Next, the QTSP generates a key pair inside a hardware security module and issues a certificate that contains those verified identity attributes. Finally, that certificate is formally bound to the natural person, so every qualified signature can be traced back to that verified identity. For qualified signatures, it's not enough to just know who the user is. You must prove that this specific person approved this specific transaction. That's what transaction-bound authentication delivers. The user performs strong multi-factor authentication while seeing the key details of the signing request. Those details are cryptographically linked to the authentication step, and the system stores a clear consent record. Architecturally, this is what turns a generic login into reliable bank-grade non-repudiation. The qualified signing flow starts when the bank assembles the contract and all required metadata. Think of this as packaging everything the trust service needs to understand what is being signed and by whom. Next, the user reviews the document and explicitly chooses to sign with a qualified electronic signature. That click triggers a redirect to the trust service. In the third step, the user authenticates there and gives consent, strongly binding their identity to this specific transaction. Once consent is given, the QTSP actually creates the qualified signature. The user's private key is activated in a hardware security module, the cryptographic signature is applied to the document, and a trusted timestamp is attached. The fully signed contract is then sent back to the bank's orchestration layer. Finally, the bank stores everything needed for evidence: authentication details, signature validation results, timestamps, and technical logs that prove who signed what, when, and with which assurance. Real banking use cases rarely mean one user, one document, one channel. That's why an orchestration service becomes critical. It can coordinate multiple signers, deciding who must sign first, who can sign in parallel, and enforcing role-specific rules. It keeps the journey consistent across web and mobile, so the user can safely switch devices mid-flow. And it manages multiple documents as a single package, enforcing version control and making sure everyone signs the exact same content. Before we dive deeper, pause for a second and notice what you've already built: a secure, scalable signing model with clear boundaries and tight flows. Next, we'll focus on how to prove it all happened with robust evidence and compliance.